Hello and welcome to Unifying IT, OT Data Management for Industrial Companies, where we are covering topics around the partnership between Element and AWS. My name is Juanita and I'm part of the marketing team here at Element. I'm super excited to welcome our speakers today. We have three accomplished speakers, and I'll start with our two guests. Thomas Cummings is a Senior Partner Solutions Architect at AWS and a member of the IoT Specialist Partner Solution Architect team. He has over 10 years of experience developing new sensor devices and software in the medical device and IoT space. Thomas has a PhD in biomedical engineering from the University of Southern California, where he developed an ultrasound imaging system designed to improve breast cancer diagnosis. That sounds amazing, Thomas. Welcome. How are you?
Doing great. Thank you. Great to be here today.
Thank you, Thomas. Our next speaker is Krishna Dodapaneni, who is a Partner Solutions Architect and also a member of the IoT Specialist Partner Solutions Architect team at AWS. Krishna has more than 10 years of experience helping partners and customers build innovative IoT products and solutions. He has a PhD in wireless sensor networks and a postdoc in robotic sensor networks. Krishna is passionate about connected solutions, technologies, security, and their services. So excited you can join us today, Krishna. How are you?
Thank you. Really excited. I'm really good. Thank you.
Awesome. Our third speaker, Jay Chow, is an engineering manager here at Element. Jay has more than 10 years of experience helping industrial companies get the most out of data, including experience at OSIsoft, helping customers obtain value from time series data. He holds a PhD in computational simulations and biomedical device sensor optimization from Rice University. Hi, Jay. Welcome. Looking forward to the discussion.
Thanks, Juanita. Really excited to be here.
Awesome. Okay, a quick look at the agenda today. We'll start by looking at the key challenges that this partnership is addressing. We'll take a look at an overview of AWS for industrial solution. Then we'll take a look at data modeling challenges and see a demo. We'll look at the architecture and also the benefits and capabilities of this integration. We'll open it up for Q&A and then we'll close out in the time allotted. And Thomas, now I'll turn it over to you.
Great. Thank you so much. So again, my name is Thomas Cummins. I'm a Partner Solutions Architect at AWS, and my role is to work with our partners and make them successful when they build industrial IoT solutions and deploy them at their customers. And so these are primarily partners that are building solutions for customers in the manufacturing and oil and gas space. That's two very popular verticals that we're focusing on. And so what are the biggest challenges we see with helping these partners? What we see is that these partners are trying to go and help customers and their edge environments, their network topologies, the types and variety of devices that they're using to bring data in with are very diverse. And so liberating the OT and the industrial IoT data is a very big challenge. It's sort of challenge number one. We can't do much about extracting insights from the data if we can't get at it. So our number one challenge is how do we liberate this data from the plant floor or from an oil and gas compressor station? Number two is how, once we have the data, what do we do to generate insights from it? So how do we use all of the AI and ML technology that AWS has with all of our AI and ML services and some of our IoT services to generate those insights? And then how do we modernize OT infrastructure so that we can extract these insights on a continuous basis with as little overhead as possible so that customers can solve business problems and not worry about OT and IT infrastructure and how all the software is running and whether it's up, the uptime is where it needs to be and it's reliable. So with the partner team is taking an approach that we're generally calling this Industry 4.0 approach for, and then in this case, we're really focusing on energy and manufacturing, and we're trying to make our partners successful to build these types of solutions. And so we need to help them be able to model assets out in the real world. So these types of customers have very high value assets, and these can be stamping presses in a machine, in a manufacturing plant. They can be compressor stations in an oil and gas compressor facility. We need to be able to ingest, process, and store that data from those assets. We need to be able to then visualize and consume that data using dashboards and things like that. So we have all these types of technologies that allow us to do those things, and we need to essentially boil this all down to give customers division, facility, plant, well level visibility. And so that's what these types of solutions are designed to do. And then you see on the bottom here is all the specific technical steps that we have to go through to help our partners build these solutions. So we need to make sure all of these are addressed. And so I'm going to get into going over a service that we have that really focuses on solving these technical challenges. So AWS has a service called AWS IoT Sidewise. This is really the foundational service that we use to build industrial IoT solutions. The service has been designed to model industrial assets out in the real world and then provide mechanisms to ingest data for those assets, process that data, store that data, and then enable it to be consumed easily by a number of different stakeholders, whether those are OT people on the plant floor, whether it's C-suite executives that want to see factory level or company level KPIs like OEE or some other KPI. We want this service enables all of that to happen. And so I'll get into a little bit more detail about the fundamental piece of AWS IoT SiteWise that is the most important and is really why the partnership with Element here has become so critical because it's proven to be the biggest challenge, and that's asset modeling. So how do we actually go about modeling and provisioning potentially hundreds or thousands of assets in SiteWise programmatically in a way that is easy for customers to understand and use, and that's what we'll get into next, which is the modeling of assets. So here's the fundamental piece of SiteWise. How do we model physical assets out in the real world within the service? And the way that SiteWise does this is it borrows, it's analogous to the object-oriented principle of creating a class and defining a class and then instantiating that to create an object. The way SiteWise does it is you define an asset model. So here we use the example of a stamping press. So we would define a stamping press model and we would give it 4 different properties. Attribute properties, which are things that are static, so things that don't change, like the manufacturing name, the model name, the serial number. We define measurement properties, which are similar to process variables, for example, so time series data, things like temperature measurements, pressure measurements from the actual sensors on the machine itself. Then we have transform properties, which are mathematical and logical transformations you can perform on the data. So for example, if we want to convert Fahrenheit to Celsius, or if we want to perform some sort of a calibration to raw data that's coming in from the sensors to create some sort of processed value. That's what we can do with transforms. And then there's metric properties. And so these are similar to transforms in that you apply mathematical and logical operations to data, but you do it over a period of time. And you apply sort of an aggregation function. So the idea would be, how do we calculate an average over the last minute that a stamping press has for one of its pressure sensors, for example? Or how do we calculate the maximum value that a vibration sensor has achieved in the past 15 minutes? So things like that, aggregation functions over a period of time. So you define all those things for a model, and then you instantiate that model 1 or more times to create specific assets. So with one stamping press model, we can instantiate it 5 times to create stamping presses 1 through 5. And once those assets are created, you can then ingest data for all those properties. Usually you ingest data for, say, the measurement properties, and then in the cloud, you're calculating the transform and the metrics. And those are all stored, all the results, both the raw data and the process data, are all stored in the managed time series database within SiteWise, and then you can access that data either through APIs or the built-in dashboard building tool, which is called SiteWise Monitor. So you either have a ready-made dashboard that you can build within the service, or you can have a custom application consume the data via APIs and do whatever you would like with it. Some partners have their own dashboards already built, and they even sell them as, their ISVs perhaps, and so they just use SiteWise as sort of a way to model the assets, store the data, the process data, and then they can consume and visualize on their dashboard tools. Perfectly fine. So that's the key piece. That's how we're approaching helping customers build solutions in the industrial space. That's how SiteWise, that's why we built SiteWise, and that's the fundamental piece right here. So I'll transition over to Jay to talk about the challenges with this data modeling.
Great. Thomas, thank you so much. And like Thomas mentioned, there's a lot of benefits of modeling assets in SiteWise and being able to pull all this industrial information together into a standard definition or representation for downstream analytics and monitoring in AWS services. However, there are a lot of challenges with pulling all this information together into a data model. What we see across industrials is that a lot of the industrials have made a lot of investments in different types of vendor applications or systems. And what this leads to are different schemas or encodings within each system. The data systems are oftentimes siloed, so it's really hard to pull the information out, let alone start linking the information together. Because there's a lack of standardization to define different sensors or equipment nomenclature, it's really difficult to start mapping key information to the data model. And oftentimes, different systems contain pieces of context, so it's really hard to piece all of the information together. Sometimes, even if there's a standard out there, the context itself may be locked away in graphical formats or engineering designs, and it's really hard to pull that additional context out. So it's very difficult to scale data models, which means that it leads to longer project times for implementation, for validation of the model. And oftentimes, because things are done manually in spreadsheets, there can be incorrectly mapped tags to the data models. And even once the models are deployed and published, there is a maintenance overhead to keep the models updated. So before we dive into the software demo on this integration with Unify and AWS IoT SiteWise, what you're going to see in the demo is how Element Unify is able to bring together IT, OT metadata from industrial source inputs. Unify has this UI specifically designed to quickly transform, extract out, and contextualize context across many different applications, standardize them to templates to essentially create a standard way to represent assets and processes. And then this integration allows this model within Element Unify to automatically be published to AWS IoT SiteWise. And as we all know, the data itself, underlying data is oftentimes dynamic, or there may be changes to the data model. Element Unify is also able to start governing and push updates directly to AWS IoT SiteWise. So let's go ahead and dive into the software demo and see how Unify is bringing together IT, OT data. Now, for the demo, let's go ahead and start with AWS IoT SiteWise Monitor first. And what you see here is a condition-based maintenance dashboard in SiteWise Monitor. And this allows operators to better monitor the health of their assets and drill down into critical assets that need more attention. Now, while this is a simple dashboard that provides a lot of valuable insights, building these dashboards as well as the underlying models usually takes about 80% of the time to set this up. And part of the reason why it's very difficult is because the information is coming in from all these siloed sources. For example, run hours could be coming in from SAP, and the equipment reference from SAP has a functional location that looks very different from the sensors that are associated for the equipment. There's a lot of context from PNIDs where the instrumentation is also named differently, let alone locked away in these graphical engineering designs. Now, Getting all this information pulled together is very time-consuming and difficult. However, Element Unify makes the design and the deployment of the underlying SiteWise models very easy. What you see right now is Element Unify, which was deployed into AWS. At the center of the screen, you see different data sources that Element Unify has connected to. These include OPC servers, like those provided by vendors like PTC or Industrial Automation, as well as systems that contain critical asset information like SAP. There's a lot of process information locked away in engineering drawings, as well as systems where there could be existing models already, including Aviva Pi Asset Framework, as well as existing AWS IoT SiteWise models. Now, let's take a look at some of the data. For example, if there's a set of process tags, you can see that the tags themselves have a lot of metadata in the columns below. However, getting this data cleaned out or getting the context cleaned out and extracted from these fields is oftentimes very time-consuming and difficult. Unify has a set of transformations that provide 180 different ways to transform the metadata from source systems. Element Unify has a no-code, low-code environment, so users can easily develop and design the data models really quickly. This is one of the transformations that's available in Element Unify and allows users to quickly build out expression to pull out information that he or she needs. So for example, if we take a look at the description field here, the description field for tags can sometimes contain equipment references, but the equipment references may not be standardized. Well, this expression allows me to just quickly pull out the equipment prefix as well as the equipment number, even though there may be gaps in the equipment nomenclature. Now, as many industrials know, the mapping process is very challenging, also because sometimes the context is not in the tags themselves. Element Unify's PNID productivity tool makes this harvesting of this context very easy. And this is an example, but a user can easily extract out the instrumentation as well as equipment references. And this really helps improve the QA, QC mapping validation process. Now, once the context is extracted out from the sources, they still need to be standardized. What you see here is the template library in Element Unify, and templates provide a standard way of representing assets and process definitions. Let's take a look at one of these. This is a pump template, and these templates support features like inheritance as well as composition, but they're also fully extensible as well. So as a user, I could easily define additional properties or parameters on top of the attributes as well as the templates. Now let's go back to the pipelines. Now, once the context is extracted out as well as mapped to the templates, you also need to be able to link all the different data sources across your different plants together. And in this case, what you see here are different OPC servers that contain tag information. These transformations that you see allow users to start integrating the PNIDs to the SAP function locations. All this information can be easily brought together. The best thing here is because the data is dynamic and changes, Element Unify has a feature called Asset Sync, which allows the model and other data sets to be kept up to date as there are changes to the data sources. And finally, once the model has been developed, Element Unify will publish these mappings to AWS IoT Sidewise. So what you see here is AWS IoT Sidewise, and we're looking at the asset models. These are coming in directly from Element Unify. And you'll notice that, for example, what we're looking at here are the attribute properties. And these capture information that could be coming from different sources. For example, anomaly detected could be coming in from AWS Lookout, and flocks coming in from SAP. We could take a look at measurements as well, and you can see the same properties or attributes that you saw earlier in Element Unify is now published to AWS IoT Sidewise. And the other thing about this is the publishing also includes the asset hierarchies. So for example, right now we're looking at the Baytown site, and we're looking at a particular pump in the Baytown site. However, because the publishing is scheduled and automatic, any updates will automatically be published to AWS IoT Sidewise. making sure that you're able to focus on what matters and focus less around all the wrangling that's needed. Great. So you saw the a demo of Unify. Now I'm going to turn it over to Krishna, and he's going to talk about how Element Unify is deployed into the AWS stack.
Thank you, Jay, for this demo. Let's look at AWS Industrial Machine Connectivity, the IMC. AWS IMC is an initiative designed to accelerate digital transformation for oil and gas and industrial operators. The AWS IMC Quick Start achieves this by bringing together ISV partners whose edge software products can liberate OT data from on-prem data stores and bring it onto AWS. ISV partners whose cloud software applications consume that data to generate insights for customers. And finally, regional and global system integrators that can deliver complete solutions to customers and develop custom applications to meet their unique needs. So what is IMC? The Industrial Machine Connectivity Framework is designed to enable customers and partners to get data from their valuable assets into AWS in a simple, structured process so they can more quickly realize the business value that is derived from that data. The reference architecture includes capability to convert customers' existing asset hierarchy definitions, for example, factory, lines, machines, tags, etc., defined in partner edge applications like inductive automations, Ignition Server or PTC Kep Server, etc., to the equivalent asset hierarchy within AWS IoT SiteWise. Now, this capability is enabled by Asset Model Converter, the AMC. You can see here on the reference architecture here, a component of the IMC reference architecture. With asset hierarchies defined within SiteWise, customers' data can be ingested continuously into AWS Cloud. Now, what we have here next is the AWS IMC extension with Element Unify. With this extension, AWS partners and customers can now leverage Element Unify to centralize, integrate, and contextualize IT and OT metadata in single-site, multi-site, multi-instance deployments and deploy the models to AWS IoT SiteWise. The following diagram here illustrates the reference architecture for the end-to-end integration between various industrial OT data platforms residing in industrial sites with Element Unify platform ingesting data into AWS services, including SiteWise and S3 Industrial Data Lake. Let's take a deep dive into the reference architecture here. Now, you see number one, partner connectivity applications like Ignition and Kep Server running on AWS certified industrial PC ingests real-time sensor data and metadata from PLCs and industrial historians. Number two, PI interfaces collect the data from sensors, PLCs, SCADAs into PI server running at plant or regional data centers. Element Unify Asset Framework Management Tool retrieves, deploys, and manages PI Asset Framework asset models, allowing the same asset model to be used in AWS IoT SiteWise. Now here, the metadata can be ingested into Element Unify through three different ways. A, file upload on the UI. B, RESTful APIs either directly or via pre-built Unify agents or integration to an iPaaS layer. C, directly via command line interface. Now, Element Unify ingests asset models and tag lists exported from the edge applications such as Ignition and Kepware. Through the iPaaS layer, Element Unify P&ID productivity tool, it automates the harvesting of asset information from graphical engineering designs. Element Unify, which is a centralized IT/OT data management platform that integrates, contextualizes, and governs asset data models from OSI PI Asset Framework, Ignition and Kepware, etc., running at the edge, and IT sources like SAP, Maximo, and performs bidirectional model sync with SiteWise. Unify can also read existing asset model data from SiteWise and then provisions the new enriched asset model back into SiteWise. AWS IoT SiteWise ingests, filters, transforms, and processes all the incoming time series data before storing both raw and processed data in a managed time series data store. SiteWise publishes an MQTT message to AWS IoT Core each time the asset property value updates. An AWS IoT Core rule publishes these asset properties and updates the messages it receives from SiteWise in a near real time into Amazon Kinesis data firehouse. Amazon Kinesis data firehouse captures data from IoT core, transforms it, and delivers the data in near real time to S3 data lake. Now, once real-time and historical data is available in S3 data lake, Amazon Lookout for Equipment can use this data to detect abnormal equipment behavior so that machine failures can be detected before failure occurs and avoid unplanned downtime. Amazon QuickSight can be leveraged in conjunction with Amazon Athena to create and publish interactive BI dashboards. I'm now going to pass it on to Jay to present the key benefits of this integration.
Great, thank you, Krishna. So in summary, you saw a lot in Element Unify, as well as a lot of value in AWS IoT SiteWise. Element Unify really focuses around integrating, contextualizing, and governing industrial metadata from many different source systems and publishes the models to AWS IoT SiteWise. There's a lot of capabilities of this integration, but I think the top three are really focused around having connectors, which can really understand the schemas and the formats from many of these industrial systems, followed by a no-code, low-code set of transformations where the software has a UI, user experience specifically designed to pull this information together very easily. And finally, because source system information is oftentimes dynamic, there could be changes, or maybe even the models have changes as system integrators as well as industrials are making changes to the models. Unify provides a way to keep all that information up to date so that the AWS IoT SiteWise models are up to date as well. And what this really results in is a faster time to insight, as well as less maintenance and overhead to maintain all the different models and the information to link the information together. So on the next slide, I'll just go ahead and summarize that there's a lot of really great services within AWS. You saw some with SiteWise Monitor as well as SiteWise model the information. And these services allow industrials to conduct IoT analytics at scale. The integration with Element Unify through the AWS Industrial Machine Connectivity Kit allows users to now seamlessly integrate all the metadata from their IT/OT systems into a comprehensive data model, and then quickly deploy and publish the model to AWS IoT SiteWise. And this just helps provide more visibility across all industrial plants, as well as faster time to insights. So we'll now go into the Q&A portion of the webinar. I'm going to go ahead and pass it to Juanita.
Thank you so much. We have a few questions. Let me see. The first question is, and this can be for any of the speakers, how long does it take to be trained up on Unify and SiteWise?
So the training for Unify and SiteWise, the Unify piece takes about 2 to 3 days. There's a core Unify training that takes a day. The specific integration with SiteWise is another course that takes a day. And if there's interest, there's also a 1-day course on advanced features in Unify to just bring more value to the IT/OT integration story.
Thank you so much. Another question we have is, can we reuse the Aviva AF, so asset framework that is imported into Unify in SiteWise also?
Yes, it's very easy to do that. Element Unify has a tool that actually connects directly to Pi Asset Framework. And this tool allows the extraction of the AF templates as well as hierarchies and load them directly into Unify. And once it's loaded into Unify, it's very easy to just set up some rules to then go ahead and publish the same model to AWS IoT SiteWise. And this is actually something that a lot of industrials have asked for, which is how do we start leveraging existing context and project work that we've done within Aviva Pi Asset Framework.
Okay, awesome, thank you. I think we have time for just one more question. and any of the speakers can take this one. Do you have a free trial that I can use with my existing SiteWise environment?
Yeah, there is a free trial, and the free trial is we could cover that in the next slide, but the free trial is a 30-day free trial and allows anyone with AWS account to just quickly launch Element Unify and get access to the software as well as this integration to SiteWise.
Thank you, Jay. Yes, as Jay mentioned, in terms of next steps, you can request a free trial. We have provided the links in the chat for easy access, but we will also include them in follow-up emails after this webinar, and we'll also share the recording as mentioned. The two methods of trying the software is through our website or through the marketplace. Additionally, you can learn more through our website. We have an Element Unify for AWS solution page, which has excuse me, tons of resources, including a video. We also have 2 blog articles that are packed with information and more details on what you've seen today, and other resources as well. We'd love to hear from you. You can engage with us in any method that suits you, either through our website, but also through LinkedIn. Connect with our speakers, tag them in your comments, follow the company pages, and we'll be happy to help. Thank you so much to our speakers for joining us today. Thanks, guys. And thank you to everyone else. We hope you enjoy the rest of your day, and thank you for joining us.